Subject: Chemistry. Types of chemical reaction. Grade 10th. Good morning, everyone. Today, we're diving into a fascinating topic in chemistry: reactions and their types. By the end of this session, you'll be able to define different types of chemical reactions and understand their significance in both scientific and real-world contexts. Let's begin. First, let's establish what we mean by a chemical reaction. A reaction is a chemical process in which one or more substances, known as reactants, undergo a transformation to form new substances called products. For example, consider the reaction 2H2 plus O2 equals 2H2O. The equation 2H2 plus O2 in 2H2O represents a chemical reaction between hydrogen gas, H2, and oxygen gas, O2, to form water, H2O. Here's the explanation step by step. Reactants: hydrogen gas, H2, oxygen gas, O2, product, water, H2O. Balanced equation. The 2 before H2 and H2O shows that 2 molecules of hydrogen react with 1 molecule of oxygen to produce 2 molecules of water. Word equation. Hydrogen plus oxygen is water. Type of reaction. This is a combination or synthesis reaction. 2 elements combine to form a compound. Here, hydrogen and oxygen are the reactants that combine to produce water, which is the product. Finally, H2O. Now, let's talk specifically about irreversible reactions. An irreversible reaction is one that proceeds in only one direction. Once the products are formed, they cannot revert back to the original reactants. For instance, when carbon C burns in the presence of oxygen O2, it produces carbon dioxide, CO2. Once carbon burns and forms carbon dioxide, it's impossible to convert the CO2 back into carbon and oxygen under normal conditions. C plus O2 equals CO2. On the other side of the spectrum, we have reversible reactions. A reversible reaction can proceed in both directions, from reactants to products and then back to reactants. Take the formation of ammonia as an example. N 2 plus 3, H2 arrow 2, NH3. In this case, nitrogen and hydrogen react to produce ammonia, but ammonia can also decompose back into nitrogen and hydrogen gas. This duality is what sets reversible reactions apart. To summarize, a reaction is a process where substances change into new ones. An irreversible reaction goes in only one direction and cannot return to the original reactants. A reversible reaction can go in both directions, allowing the products to revert back to the reactants. Now that we've covered the definitions, let's think about how this connects to the real world. Irreversible reactions are often seen in combustion processes, like burning fuels in cars. Once burnt, you cannot get the original fuel back. Reversible reactions are critical in biological systems. For instance, in our bodies, carbon dioxide and oxygen recycling during respiration is a reversible process. Understanding these reactions helps us in industries, environmental science, and even day-to-day life. Before we wrap up, does anyone have questions or examples of reactions they've seen in everyday life? Feel free to ask. It's always fun to explore this subject together. Thank you for your participation today. Catch you next time as we explore even more exciting topics in chemistry. Remember, continue observing the world around you and think about the reactions that make everything possible. Thanks for watching Forces School System YouTube channel. Like, comment, share, and subscribe. Stay healthy.